Okay, let us see this example about steel power. A car of mass 1,000 kilograms has a maximum speed. Remember here, maximum speed means acceleration is 0. A maximum speed of 150 kilometers per hour on a level ground and a level rough road with the engine working at, so they are giving us power. So in our solution, we can first sketch. Let's draw a simple sketch. We have our car. That's going to be our car. It has 1,000 kilograms. Of course, we're going to be having resistance. It will be now 1,000 G. We are going to be having a force that is going to be pulling it in that direction. Remember, from our power equal to FV, this force is going to be now equal to P over V. That's the force that is going to be pulling our car in that direction. So our force is which is going to be P over V. Okay, so they are giving us this and then they are giving us the velocity. Find the coefficient of friction between the car and the road if all the resistance is due to friction. So we are going to be having friction. Of course, it's already going to be acting in opposite direction. It's going to be mu r. It is easy. So what do we discuss now? We have our power as 6 kilowatts. So you convert them to watts, which would be 60 times 1,000, and this would be watts. So our power here is going to be 60,000 watts. Okay, then we have our V, the velocity. So our velocity is equal to 150 kilometers per hour, which we can going to convert meters per second. So it gets then times every kilometer has 1,000 meters over every hour has 360 seconds. So our V here is going to be 125 over 3 meters per second. Okay. So here we have this, we have this. Then we need R from there. So our R is going to be 1,000 G. So which would be 1,000 times 9.8. So our R is going to be 98 Newton. So we have also our R. So from there, so now our direction is going to be, that's where our direction of acceleration is going to be. So from our, if we have resolved it in this direction, you know that our resultant force is equal to mass times the acceleration. So what is pulling it in this direction is this P, is P over V, then minus the resistance mu R, equal to the mass, which is 1,000 times A, which is 0. A is 0 because we are at maximum speed. At maximum speed, there is no change in velocity. And if there is no change in velocity, it means that there is no acceleration. So from here, we want, if I take this inside, I have mu R equal to P over V. So my mu into my R, which is 9800, equal to P, my P, which is 60 over 1,000 over my velocity, which is 2,125 all over 3. And from there, my mu is going to be, we first said 125, this one, divided by 3. Then we say 60,000, divide by answer. Then we divide by this also. So the answer is divided by, so here I'm getting 0.14694 decimal places. So that's the coefficient of friction. The one that this is part A. In part B, given that the attractive force remains constant, so this remains constant, And the non-gravitational resistance is, in both cases, varies as the square of the speed. So now, this frictional force, the new frictional force is going to vary as the square of speed. Find the greatest slope on which the speed of 120 kilometers could be maintained. Okay, so from there, they want us to get the speed. So we are telling us that the new frictional force we are having is going to be, they're telling us that now the frictional force, friction, which is mu, let me call it mu 1 R1, they're telling us that varies as the square of velocity. So from there, which values are they giving? Okay, to remove this, we say this is going to be mu 1 R1 equal to K V squared. Hope you know that. How to remove the proportionality constant? I need to remove the proportionality sign, introduce a proportionality constant. So from there, what do we have? They are giving us now the new speed. So RV here. So RV here is going to be 120 kilometers per hour, which is going to be 120 times 1,000 meters over seconds in 1 hour. So that RV there is going to be, these two zeros go, this goes there. They're going to be having 100 over by this 3 meters per second. So our twist is to look for this. Now, remember, they told us that the attractive force, this one. Oh yeah, the non-gravitational force, resistance in both cases varies as the square, but they told us that the attractive force remains constant. Now, if we have our velocity there, as you can see, I think you can see it there when you press this. That is the 100 over 3. But now, remember that I told us that the attractive force remains constant and the non-gravitational resistance in both cases varies. So meaning in this case and in this case, when we want it inclined, they vary. So meaning also here, if this one, it means that now here, also mu r is also equal to k v squared. Because they tell us that in both cases, the attractive force remains constant and the non-gravitational resistance in both cases varies. So, meaning here also, this non-gravitational force, the friction, is what I'm saying. Non-gravitational force means the friction. It's varying also with the v squared in this. So, we need this k. So, this one, first of all, we saw that this one, all of this was giving us P over V equaling to K into our B. Now here our B was 125 over 3, the whole square. So this one was giving us, it was giving us 6000 over 125 over 3, the whole square, equaling to K into 125 over 3, sorry, this is non-square, over 3, the whole square. And from there, our k is going to be, so from there, we shall get so here, so in my case, going to be 0.82944. So why am I using this? Because I want this. I want the new friction of the non-gravitational force, so I don't add it. So it means that now if I have this, I need, because this one is going to work with this velocity. So that's why I'm saying when we have the first one, its velocity is this. But now when I have the new friction, its velocity is going to be this. So now from there, our mu 1 R1 is going to be 0.82944 V squared. So now I need this new frictional force, which is M. This one is working with its velocity, which is over 3, the whole square. So now my new gravitational force is going to be so here my new frictional force is giving me, get 1000 divided by 3, we square it, then times 0.82944. So this one is giving me 921.6 newtons. So meaning now, if now I'm to sketch, what does it mean? It means that now if I'm to sketch the new diagram, remember we want this angle here, theta. So this is going to be our time, it's going to be having still 1000 G. Now this is going to be our R1, the new gravity. Then we are going to be having, the force is going to be still pulling it because realize that this one remains unchanged, it's constant, because of course you can't change the work of the engine, the power of the engine, just because you are slow, you are getting up the hill. Now, here if you solve this weight, this one is going to be 1000 G sine theta, and then we are going to be having a frictional force M1R1. Okay, so that's it. But remember, we have the whole of it. So this one is going to be 100 G cos theta. So from there, remember our acceleration is going to be in the other direction. In that direction. So that's where our acceleration is going to be. So if you resolve in that direction of the acceleration, remember our force R is equal to ma. So what do we have? We have now, what is pulling it in this is going to be P over V. So we have, in that direction we have P over V, then minus, P over V, we told us that find the greatest slope at which the is, okay, P over V, then minus the opposing forces. We have this, which is 1000 G sine theta, then minus also this one, mu R equaling to M into 0, because we are at maximum speed. So implying this one is going to be 60,000 divided by now our velocity which we are using, the velocity we are using is this 10 over 3, then minus 1000, 9.8, then sine theta, we want this angle. Then minus this one is 921.6 equaling to 0. So from there it's that our, when we take everything this side, I'll be having now this. So here my sine theta is going to be 0.0896. So my theta is going to be it's going to be here. Okay, let me show you here. So here our velocity, remember the force this engine is working at the maximum speed there. So this one is 125. So this is where I made it. And simple error. This one is going to be 125. Okay, so when we press this on the calculator, we have our sign theta here is also changing to 52.9, and we press an inverse of that. Get 3.03 degrees. That's going to be the angle which we need to incline this pen so that the force, so that the speed of 120 kilometers is maintained. Here, why we used this? Because this speed at which the engine is working, it is not going to change. That's why it's at maximum, and that's why we used even this to be 0. So that's, members, we are going to see my examples. See you.